All right, let's talk about one of the absolute cornerstones of iOS development, Grand Central Dispatch, or as we all know it, GCD. Specifically, we're going to zero in on that fundamental choice you have to make all the time. Do I use a serial queue or a concurrent queue? Trust me, getting this right is pretty much everything if you want a stable, fast app. You know the feeling, right? You're hunting down a crash, or maybe some piece of data just gets totally scrambled, but you can't make it happen on demand. It works, and then boom, it breaks. I'd bet that 9 times out of 10, the real culprit is a concurrency issue, what we call a race condition. It's where different bits of code are fighting each other, and this is the exact problem we're here to solve. So let's start with our first weapon in this fight, the serial queue. Whenever you hear serial, I want you to think order, predictability, and above all else, safety. I mean, the name really says it all, serial. A serial queue is basically a single file line. It's super strict. It takes the first task you give it, runs it, and it will not even look at the next task until the first one is completely totally done. First one in is the first one out. No exceptions. The way it works is just incredibly simple. You add task 1, it runs from start to finish. And only when it is 100% complete, can task 2 even think about starting. This is its superpower. That one-at-a-time execution means the order is always guaranteed. It's locked in. So where does this come in handy? Well, it's absolutely crucial anytime you have something, a shared resource, that can't be touched by 2 things at once. Just imagine 2 tasks trying to write to the exact same file at the exact same time. You'd end up with a mess of corrupted data, right? A serial queue prevents that. It makes sure only one write happens at a time. It's perfect for things like database updates or changing properties that are shared across your app. Okay, so that was the safe and steady route. Now, let's talk about the fast route, the concurrent queue. This is the tool you pull out when you want to unleash the raw power of those multi-core processors we all have now. A concurrent queue is pretty much the polar opposite of a serial queue. Think of it less like a single file line and more like a supermarket with like a dozen checkout lanes all open at once. It can grab a whole bunch of tasks and start running them all at the same time, in parallel. GCD handles all the complicated stuff behind the scenes, managing a pool of threads for you. Now this right here is the most critical thing to get about concurrent queues. Pay attention to this. Even though the tasks are started in the order you add them, first in, first out, there is absolutely zero guarantee about the order they will finish. A really short task that you added third could easily finish way before a huge complex task that you added first. This is where all its power comes from, but it's also where the danger is. So when do you use this powerful tool? You use it when your tasks don't depend on each other at all. Think about it. If you're downloading a bunch of images for a gallery, right? Each download is its own little job. They don't need to know about each other. Running them all concurrently means your app gets the data way, way faster. It's perfect for stuff like network calls, heavy-duty image processing, or really any background work that can be split up. So now we've got these 2 powerful tools, right? One gives us perfect order and safety. The other gives us incredible parallelism and speed. And this brings us right to the heart of the matter, the core trade-off you're always making with concurrency. Seriously, if you remember only one single thing from this whole explainer, make it this. This is your mental shortcut. Need to protect some data and make sure things happen in a specific order? Serial queue. That's safety. Need to blaze through a bunch of independent tasks as fast as humanly possible? Concurrent queue. That's performance. Safety versus performance. Let's just break it down one last time side by side. The execution model, one at a time versus multiple at once. The order guarantee, completion is guaranteed with serial, but with concurrent, nope, not at all. And that brings us to the primary goal of each. For a serial queue, it's all about threat safety. For a concurrent queue, it's all about raw performance. Seeing it laid out like this just makes it crystal clear, doesn't it? You know, making this choice isn't just some academic exercise. The stability, the responsiveness, pretty much the entire feel of your app hinges on getting this right. So let's talk about what's really at stake here. If you go and use a concurrent queue where you really needed a serial one, you're just asking for trouble. You're inviting those nasty race conditions. Yeah, the same ones we talked about at the beginning. You could also create deadlocks where parts of your app just get stuck waiting for each other forever. And on the flip side, if you run a long, heavy task on the main serial queue, you'll get that bug everyone hates, the frozen UI. Choosing the right queue is absolutely essential. And listen, getting this right isn't just about fixing the bugs you have today. This understanding, serial versus concurrent, is the absolute bedrock for everything else. We're talking more advanced stuff like dispatch barriers, all the way up to the modern async await syntax in Swift. You have to master this first, and then you're ready for all the cool stuff. So I'm going to leave you with this question to chew on. Have you ever been that developer just pulling your hair out over a bug that makes no sense, only to finally realize you were trying to change the same thing from two different places at the exact same time? If you have, then you already know deep down exactly why this all matters so much.